Okay, hello guys, good day. So ito yung topic natin for today. That is pre-stress concrete design. So we are solving the past board problems and current problems in the structural design. Okay, so situation number one. Sabi niya, there's a beam 250 millimeter wide by 450 millimeter deep. Then the initial pre-stressing force 600 kilonewton. Now assume that there is a loss of 15% so service loss. So first question, what is what's the final compressive stress in the beam if the pre-stressing force is applied at the centroid of the beam? Okay, let's take note of this guys, na kapag ka sinabing centroid of the beam, okay, ayan, pinula ko, nakabold pa, tapos naka-underline pa, okay, ayan no, centroid of the beam, ibig sabihin nun, walang eccentricity. Okay, there is no eccentricity. So the solution there for the first problem, okay, is just simply negative P over A. So here in our class, we will make that arbitrary sign that negative is compression and then the positive would be tension. Okay, so yeah, ayun, I think you already reviewed the first topic about the compressive effect of the pre-stressing force, the bending effect of the pre-stressing force, and then the bending effect of the gravity loads or the applied loads. Okay, so first things first, in computing the pre-stress concrete design, we need to know the area. First things first, okay? Then the second thing is the moment of the inertia. Dapat dyan hindi kayo papalya. Dahil pag pumalya kayo dyan sa area tsaka sa moment of the inertia na yan, all of your calculation will be uh, already ruined. Okay? So, first problem, final compressive. He's asking for the final compressive stress. So, what we are going to use if there is a loss of pre-stress in the problem, then nawalan ng 15%. This is what dun sa topic natin sa first part kanina, which is losses due to shrinkage, due to slippage, due to temperature, due to creep. Okay? So, sama-sama powers na sila dito sa 15%. Okay, so, yan. May initial stress, 600,000 Newton. Then, hindi lahat yun nagagamit. So, nagiging 510,000 Newton as per the problem. Okay? So, due to compression, okay, pag in-apply siya below the neutral axis, it would create a bending like this, wherein the upper portion of this beam is subject for flexural positive stress. Then the bottom is subject for negative stress. Okay? So, ayan na. So, remove natin yung annotate. Okay, ayan na. So, ayan. So, okay na ba guys? Yung screen? Okay na ba? Yung screen, my dear students? Okay. So, share natin to. Screen. Okay. Sige then. Okay, so due to pre-stressing force, if it is located at the distance eccentricity E below the neutral axis, then it would create a bending like this one. At ito yung susi sa pagsosolve natin guys. If the pre-stressing force is located bottom, okay, below the neutral axis, it would create a positive pre-stressing force, stress, flexural stress for the beam sa taas, negative sa baba. So the first one, the prestressing tendon sa the center of the beam. So ganito lang ang solution dyan guys. Negative P over A lang yan. Ganyan lang yan kasimple. Then number 2, what is the final compressive stress in the beam if the prestressing force applied 100 millimeter below? Okay, 100 millimeter below the center of the beam. So it would be like this one. Just negative P over A, then minus P. Okay. Yeah, naka-minus na siya doon. So dapat ganyan na lang siya. Negative minus minus PE C bot over I. So what we are analyzing is the bottom fiber. So we are going to consider the distance from the neutral axis up to the outermost compression, up to the outermost bottom fiber. Okay. So by manual calculation, we're going to input that negative P over A. So that P, that is the final stress, which is final force, which is the 510,000 Newton. So P over A, then minus, yan, para hindi maulit, no? So minus 510,000 Newton. E, the eccentricity. Remember always, guys, that the eccentricity is measured from the neutral axis papunta doon sa inalalagyan ng pre-stressing force. Okay, maraming nagkakamali dyan. Okay, na akala nila yung 100 na in-specify ng problem is the eccentricity, pero yun pala is distance yun mula sa bottom papunta sa stressing force. Okay, so CBOT, since rectangular, kalahati lang siya, 225. Then the moment of inertia. So we could generate answer which is charan, that is negative 10.578 megapascal. Okay. So for more questions, I would accommodate your questions later after the presentation. Okay. So number 3. Number 3. What's the maximum eccentricity at which the pre-stressing force can be applied without producing tensile stress in the beam? Okay, ito yun guys. Kapag ka nag-pre-stress tayo, mostly na natitension yung kinalalagay ng maximum tension after pre-stressing is on the top fiber. Okay? Lagi yan guys, top fiber. Lalo pag mga simply supported na mga beam na ganun. Tapos yung maximum compressive stress is kunin nyo na lang yung summation ng compressive stress sa bottom fiber. Okay? So since dito sinabi niya what what is the maximum eccentricity to produce a zero, okay, tensile stress in the beam. So ang gagawin lang natin dyan is 0 equals negative P over E A plus PEC top over I. Bakit walang moment, sir? Kasi sabi niya dito sa problem, hindi naman niya pinakonsider yung moment. Okay? Ayan, hindi niya pinakonsider yung moment. Wala naman. Okay, so we would generate na, yan, that is 75 mm. Okay? So, may mas madali bang paraan sa pagsusolve ng pre-stressor? Kasi paulit-ulit kong yung tinatype, tapos ini-store values. Minsan nagkakamali ng nilalabas yung calcu ko. My calcu is not showing the right answer. So, I believe, parang beauty queen, no? I believe that the more na madami kayong pinipindot sa calcu is the more na prone siya sa error. Ang isang diskarte dyan, kung mas preferred nyo ang manual calculation, kunin nyo muna itong negative P over A, store nyo sa A. Kunin nyo itong PEC bot over I, store nyo sa B. Tapos yung MC over I naman na susunod sa C. Ngayon, Kung ayaw nyo ng paulit-ulit, we can use this Caltech. Okay. Itong Caltech natin. So, meron tayong beam na ang width niya is 250 and it has a height of 450. Okay, so yung area niya is 250 times 450. That is 112 to 500 and it has a moment of the inertia na 1894375 which is pares lang din siya dito, no? Yung 194.4375 times 10 raised to 6. So, we have an eccentricity na 100 below the neutral axis. So, using mode 32 in your F789 SGA, okay, paras lang din yan sa FX 570ES at 991ES. Mode 32, we are using the linear mode AX plus BY plus equals 0. So, we're going to use this relationship. Okay, pagka mode 32 nyo guys, shift mode, tapos press nyo yung arrow down ng calculator ninyo, yung ito. Yan, shift mode, tapos i-press nyo yung down dito. Then, pagka-press nyo yung down, then makikita nyo yung stat which is nasa 4, then go to 1. Okay, that is shift mode. Pag nakapunta na sa mode 32, then pindot nyo yung shift tsaka yung mode. Then, shift mode, tapos baba na arrow. Then, 4, makikita nyo dyan sa 4 yung stat. Tapos yung 1, frequency on. Okay. So, ayan. Makikita nyo ngayon itong ganito na itsura. X, Y, frequency. So, ang i-input nyo dyan guys, sa X, Y, tsaka frequency is ito. Sa X, ito yung due to axial force. So, ilalagay nyo dyan yung force. Tapos, dito naman sa Y is yung ina-analyze ninyo na fiber since mapatop or bottom fiber due to axial ng pre-stress, that is negative compression pa rin siya. Okay? Then the frequency, that is just input nyo 1 divided by the area. So suggested ko guys, itong area store nyo na yan sa A. Okay? Store nyo yan sa A. Tapos yung moment of the inertia naman, store nyo sa B. Okay? Yan. Tapos, yung susunod naman is due to bending ng pre-stressing force. So that is just simply PE, yung pre-stressing force times the eccentricity. So dapat itong pre-stressing force naka-Newton at yung eccentricity is in millimeters. Okay? Then, since for number 2 is tinanong niya is what's the final compressive stress in the beam? Okay? So sabi ni sir kanina, final compressive stress is mostly nangyayari yan sa bottom fiber ng beam. That's why dito, kinonsider ko is negative sibot. Okay? Yan. Since baba is negative sibot, therefore yung taas mamaya is positive C-top. Then ito lang ay 1 over IG, which is yung moment of the inertia is in-store natin sa B. Excuse me. Then dito naman is yan, general equation to. Moment ultimate. Tapos C-bot. Dito is dapat positive siya. Kasi yung moment is magkukos yun ng bending na pababa. Okay? Yan. So 1 over IG din siya. So dito, okay. So ang i-inputan lang natin since wala namang moment, ang i-inputan lang natin is itong mga nandito. So that would be PF 510,000. Then ito naman is 510,000 multiplied sa eccentricity na 100. Okay? Then dito, compressive, that's negative 1. Then dun sa frequency, that is the 1 over the area. For the PEC naman, negative C-bot, that is negative 225. Then ito is 1 over the moment of the inertia which is stored at B. Okay? So, pagkatapos nyo doon guys, pindot nyo lang yung CA which is yung ito. Okay? Then after that, for F17, 718 SGA, pindutin nyo lang yung shift ups for 5, which is shift, tapos yung ups, then makikita nyo yung numbers dyan, 1 to 8. So, punta nyo yung number 4. So, pindot nyo yung number 4, tapos yung number 5, at ang lalabas na number 5 is summation of xy. So, that would be negative 10.577 megapascal. At yan ay parehas lang siya dito sa dito. Okay? Yan. So, actually, itong Caltech na to is kagabi ko lang ginawa. Okay, you can also make your own calculator techniques para mas mapabilis yung solving ninyo. Okay, during our review din sa review center, ayun, nagde-develop kami ng sarili naming Caltech. Okay, kasi may mga internal quiz kami. So, nagbabanggaan lahat ng schools na Manila at province. So, pabilisan ng pagsosolve. So, sa board exam, time is precious. Okay? So, yung every minute na matitipid natin sa pagsosolve, ipupukol na lang natin yon sa ibang problems na nangangailangan ng atensyon. Okay? So, situation number 3. Situation number 3. Situation number 3, ayan. Dito, ilan daw yung eccentricity na kailangan para mag-produce ng zero na tensile stress. Okay? Okay, tensile stress. So, maximum tensile stress is nasa top usually. Okay? So, that is, net lang yan guys. To edit, so since may nilabas na siya, okay? So, since may nilabas na siya na value, to edit ngayon is, gagawin nyo lang is shift ups, then 8 2. Okay, shift ups, okay. Shift ups, tapos 2. Okay? To edit, let's just simply shift ups 2. Ayan. Okay, shift ups 2 lang siya guys. Okay? So, ayan. Then, using the choices. Okay? So, gagamit na lang tayo ng choices para sa dito. So, I'm pretty sure may mga choices dyan. So, ayan, ayan, okay, so negative due to compression, tapos positive, ito naman is due to bending ng pre-stressing force. So, same lang siya ng input sa kanina dito. Dito lang tayo magkakatalo, which is magsasubstitute tayo ng value sa choices. Wherein, pag ginamit natin yung syntax natin na shift ups for 5, okay, sa 789 GA, or shift 135 sa 991 ES or 570 ES, it would produce a 0 megapascal. And tips number 1, if you are making box solve from the choices like this one na problem, pag may napalabas na kayo, like nito, say letter A is gumamit tayo ng 75 mm choices yun sa board exam. Tapos, napalabas natin 0, which is yun yung hinahanap ng problem na mag-0 daw yung tensile stress. So, wag ka na humanap ng iba. Pag nahanap mo na, wag ka na maghanap ng iba. Okay? Yan na yung sagot. Okay? So, next problem tayo. Situation number 2. The section about double T. Yan yung problem natin guys. Double T. Okay? The section about double T pre-stress joints is shown in the figure. The joists are simply supported on a span of 7.5 meters and are pre-tension with total initial. Okay, so may dalawa dyan. There is 2 pre-stressing tendons there, but it is said in the problem that there is already total force, initial force of 1,100 kilonewton from low relaxation strands. The joist supports a total dead load 2.3 kilopascal. So ito yung titignan nyo if it is including the beam weight or excluding the beam weight. So if the dead load that is given is said that it includes the weight of the beam, therefore no need more to compute for the dead load or dead weight of the beam. Okay. So Rather, if it is not included, so you're going to compute it. Next is live load 6.2 kilopascal. And it is said that there's a loss of 20% at the service loads. Unit weight of concrete is 24 kilonewton per cubic meter. So mabait siya kasi binigay na niya yung area at yung moment of the inertia. Okay? Calculate the stress at the top fibers of the double T at due to initial pre-stressing force only. So solving number 4, okay? So ito yun guys. Okay. Kung gagawa kayo ng spreadsheet nyo for the actual structural design, kung gusto nyo magpunta sa design, is ayan, may mga given, tapos may units. Ayan, para mas madali siyang isolve pag formula na lang siya. Okay? So, we have initial, may loss tayo, may final, may area, may moment of the inertia, may length, may setup, C bottom, E. Dead load, pag isa mo lahat ng dead load. Live load, ito. Okay. Then, we can get already the moment. Okay? So, that is 1.43 times 10 raised to 8 Newton millimeter. So, dito, we have 2.3 kilopascal, which is pag multiply natin sa 2.4, saan galing tong 2.4, sir? Where does the 2.4 comes from? The 2.4 is ito. Pag meron tayong pressure at gusto natin yung ikalat sa entire length of the beam, multiply lang natin siya sa kanyang tributary width, which is 2.4 para maging kilonewton per meter. Okay? So, same true para sa ating live load na 6.2 kilopascal. We're just going to multiply that 6.2 sa 2.4. Okay? So, for the simply supported and uniformly distributed load, meron tayong formula dyan. Ito na. That's the W squared all over by 8. And we will generate a moment of 1.43 times 10 raised to 8 Newton millimeter. Okay? Advice number 2, in terms of solving stresses, especially in strength of the materials, steel design, and all of your subjects in the design subjects. Gawin yung forces nyo is in newtons, tapos yung units naman ng measurement nyo is in millimeters. Okay? So, ito yan, by principle. By pre-stressing force, yung nasa taas tension, yung sa baba is compression. Okay? So, number 4, yan. So, tayo number 4. Number 4, using mode 3-2. Okay? Using mode 3-2. Ano bang hinanap sa number 4? Calculate the stress at top fibers due to initial pre-stressing force only. So, the problem said due to initial pre-stressing force only. So, the problem is neglecting the stress caused by the gravity loads, okay, by the applied loads. Okay, so we're just going to solve it by the pre-stressing force, the axial effect of pre-stressing force, and the bending effect of the pre-stressing force. No data since simply support. Okay, tanggalin na lang natin ito. Yeah. Okay, so initial pre-stressing force, yan yung wala pang losses, so that is 110,000 Newton, 1,100 times 10 raised to 3 newtons. Tapos ito naman is yung ito, multiply natin sa kanyang eccentricity. So yung gagawin natin dyan is ito na lang. Ayan. Okay, so we have the eccentricity. Ito. So that is, ito yan guys. Okay. Itong P initial multiplied by the eccentricity. So dito, that's just simply negative, and as what is said by Sir Miner kanina, that's just simply 1 over by the area. This one, usapang due to bending effect na ng pre-stressing force, that is just simply 1 over by the moment of the inertia. So that is just mode 3-2. Then shift mode for 1, no? Shift, then pindot new mode, then press your arrow down, then 4, tapos 1. Okay? In 10 minutes, this will end. Okay? Pasok ulit tayo mamaya, guys. Okay? So, ayan. Sa problem number 2. Okay? So, yan. So, ito, since, ano ba yung pinapakonsider sa number 4? Top fiber. Okay? So, when it is top fibers, we're going to use the top. So, C top. This is positive 88. Okay? So, shift ups 45 or shift 135. That will generate into 4.386 megapascal. That is the stress at the top sa may mid, okay, ng ating beam due to the initial pre-stressing force. Then number 5, mode 3 to ulit tayo. Okay, anong tinatanong sa number 5, sir? Number 5 is calculate the compressive stress at the bottom fibers of the double T at midspan due to initial pre-stressing force only. So, compressive force sa bottom. So, ang gagawin lang natin doon para hindi na tayo mag-input is mag-edit na lang tayo. To edit, shift ups, then 2. Okay, shift ups 2. Yan, shift ups 2 lang yun, guys. Okay. Yan. So, that's just simply, since C-top na kanina is, anong inanalyze natin kanina? That is the ano na yun kanina? Number 4. That is number 4. Ang inanalyze natin is top fiber. Ito naman is bottom fiber. Okay, so dito is si bottom. Number 5. Dapat si bottom yan. Okay. Yan. That is si bottom. Okay. So, pagka kay si bottom na, dapat siya ay yan, negative. Okay. Yan. So, paano mo nasabing ganyan, sir? Dahil dito. Okay, yan yung effect ng pre-stressing force pag yung pre-stressing force natin is nasa below the neutral axis. Okay. So, number 5. Return ito number 5. Ayan. In-edit lang natin. So, ito yung magiging values. Okay. So, same pa rin dito sa first line. Sa second line, P pa rin, initial, multiplied by the eccentricity. Then, we'll just going to change this one in the input. After nyo ma-change yan, wala kayong babaguhin dito kasi 1 over the moment of the inertia. So, shift ups for 5. Then, it would generate automatically a negative 35.495 megapascal. So, that would be the answer for number 5. Okay, that is compression. Next one, number 6. Calculate the additional load in kilopascal such as the stress at the bottom fibers of the double T at midspan. Due to service load and pressure force will be 0. Okay, ilan yung pwedeng pang may dagdag? Okay, so number 6, ito lang yun, guys. Due to actual load effect of pressure force, all throughout negative. Mag-analyze man tayo ng top fiber, negative pa rin siya. Bottom fiber, negative pa rin. Due to bending effect of pre-stressing force. If it is below the neutral axis, ito yung mangyayari. Taas is positive, baba is negative. Yun yung second line ng equation natin doon sa Caltech natin. Then the third line is due to bending of the applied loads. So it would create a negative stress sa top fiber, then positive stress sa bottom fiber. Ito lang yung tatandaan nyo yun, guys. Ito lang mga tatlong to. Kung ano yung magiging epekto nung ilalagay nyo na loads. So ito lang yan. Kung taas ang i-analyze natin, isa-summation lang natin lahat yung forces sa taas. Kung bottom naman, isa-summation lang natin lahat yung nasa bottom. Okay? So, number 6, mode 3 to. Okay? So, pwede na namang i-edit lang natin. Okay? So, dito is mag-consider na tayo ng moment. Okay, so, pre-stressing force, negative, then 1 over A. Pre-stressing force sa top, that is, okay. So, I think this should be C-top. C-bot. C-bot, negative C-bot. Okay, negative C-bot. Okay, then I over G. Then M ultimate, that is positive C-bot. So, bottom yung i-analyze natin para sa number 6 kasi dito sa problem sabi niya, stress at the bottom fiber. Ayan, okay. So, yan. Inputan lang natin yan ng values dito. Okay, first line, that is the due to action of pre-stressing force. Second line is due to bending sa bottom. This is the C-bot negative is P. This is P multiplied by eccentricity. Then, ito naman is yung moment. Yung moment natin is kay E150. Okay, E150. Siya, okay. That is, ayan o, 1.43 times 10 raised to 8 Newton millimeter. Then, C-bot din siya. Then, I over 1 over by I. So, shift ups for 5. Okay, using shift ups for 5, it will generate already a negative 8.087 megapascal, which is the answer. Okay, not totally. That is the stress at the bottom. Ibig sabihin yan, using the pre-stressing forces, kahit niloadan siya ng dead load at live load kanina, ganito pa rin yung itsura ng beam natin. Hindi nga lang siya ganong kita sa actual. Kasi naka-cumbering siya, maliit lang. That's why dito naka-close. Dito. Resultant bending diagram due to service dead load, live load, and the final pressing force. So the problem want to know the additional load to make the stress at the bottom of the beam at midspan be 0. So gagawin natin dyan guys is ganito. Yung 8.087 megapascal na yan, i-equate natin yan sa moment additional times the C-bot kasi yan ay stress sa bottom divided by the gross moment of the inertia. Okay, so substituting the values simultaneously, we will generate an additional moment of 57.244 kilonewton meter. Okay, and using that moment, we will just equate it to WL squared all over by 8, wherein L equals 7.5 meters. Therefore, W additional is 8.141 kilonewton per meter. At para ibalik na rin siya sa pressure, we will just going to divide it by the tributary bid, which is 2.4 meters. That would generate into P equals 3.392 kilopascal, which is kamukha niya na ito. Okay, so i-end muna natin doon for the meantime. Okay.